Hello, my name is Ilman Hakim, Muhamad Jamaludin, and my metric number is B0919102216.
Hello, my name is Muhammad Nurul Fariz bin Zawil Anuar, and my metric number is 0919100077.
Hello, my name is Muhammad Fahmi Hakim bin Muhammad Sabri. My metric number is B0919100250.
My name is Mustakim Salam. My metric number B09110101.
Hi, my name is Zulfikri bin Ariff. Metric number B0919100017.
So this car uses an 8-inch solid disc type. As you can see, this is the brake rotor known as the brake disc. This is the wheel hub. These four are the wheel studs, and this is the brake caliper, floating caliper setup. As you can see inside here, these are the brake pads. Okay, still okay, still thick. These are the clip are the anti-rattle clips. This is the retaining pins. Okay, this is the bleeder valve, bleeder screw and bleeder cap. Okay, so this is the bleeder valve, and then this is the inside here is the slider pins. This is the slider pin boot. Also, this is also known as the caliper pin, and this is the brake cylinder inside here, the brake cylinder, and this is the brake cylinder boot, dust boot. This is the brake hose where brake fluid flows inside here, and then pushes the piston, and then pushes the brake pad into the rotor to slow or stop the car. So for rear brake setup, this car uses hydraulic drum brake system. So as you can see here, this is the brake drum. These four are the wheel studs. Behind here is the back plate. This is the brake hose where pressurized brake fluid flows inside here. This is the parking brake or handbrake cable. Behind here is the bleeder valve. This is the bleeder screw. This is the bleeder cap. Okay, and then inside here are the drum brake components such as the brake shoe or the brake lining, the brake adjuster lever, the return spring, and above here inside here is the rear brake cylinder or rear brake pump. So for the brake components inside the engine compartment, you can see that behind here, this is the brake servo, also known as the brake booster, and this hose right here is the brake vacuum hose, which connects to the intake manifold, and this is the brake fluid reservoir, which holds the brake fluid inside here. You can see here there is a maximum and minimum level readings for brake fluid. This is the brake fluid reservoir cap. This is where you top up your brake fluid for bleeding procedure. And to the side here you can see that there is a brake fluid level sensor right here, and this is the connection. To sense if there is insufficient brake fluid inside the system, there will be a warning light appear on the dash to alert the driver. And then below here, this is the brake master cylinder, which pumps the brake fluid throughout the system. And if you follow the lines here, it will connect to a proportioning valve. This proportioning valve distributes the brake fluid to the front and rear brakes.
When the driver depresses the brake pedal, the push rod attached to the brake pedal moves towards the brake servo. The vacuum generated in the brake servo multiplies or boosts the braking force. The force is then converted into hydraulic pressure inside the master cylinder by pressuring the brake fluid from the reservoir. The pressurized brake fluid moves through the brake lines towards the proportioning valve. The proportioning valve distributes the brake fluid to the front and rear brakes, engaging the brake mechanism. When the parking brake is engaged, the parking brake cable tensions and the parking brake lever squeezes the car's rear brake shoes onto the brake drums, holding the car firmly in place. The brake warning light appears on the dash. When the parking brake is disengaged, the parking brake cable slacks and the parking brake lever retracts the car's rear brake shoes back into its original position. The brake warning light disappears from the dash.
Depress the brake pedal several times with the engine off until there is no chain in the pedal travel. Depress and hold the pedal, then start the engine. If the pedal goes down slightly, operation is normal. Start the engine and turn it off. After 1 or 2 minutes, depress the brake pedal several times slowly. If the pedal goes down further the first time but gradually rises after the second or third depression, the servo is airtight. Depress the brake pedal while the engine is running, then stop the engine with the pedal depressed. If there is no chain in the pedal travel after holding the pedal for 30 seconds, the servo is airtight.
Remove the floor mat and turn up the carpet. Measure the brake pedal height from the floor. Disconnect the stop lamp switch connector. Loosen the operating rod lock nut. Adjust the brake pedal height by turning the operating rod with pliers. Turn clockwise to raise the brake pedal and anti-clockwise to lower it. Measure the brake pedal height. Readjust if necessary. Once the adjustment is done, secure by tightening the lock nut of the operating rod. Loosen the rod lamp switch lock nut. Screw in the stop light switch until it contacts the brake pedal stopper, just before the brake pedal is caused to move. Back off the stop light switch half to one turn and secure by tightening the lock nut. Tighten the road lamp switch nut. Connect the connector of the stop lamp switch. Check that the stop lamp is not illuminated with the brake pedal unpressed.
Okay, press, release, press, release, press, release.
Return the carpet and floor mat. Check the brake handling.
Connect a circuit tester to the stop lamp switch. Check whether or not there is continuity when the plunger of the stop lamp switch is pushed and when it's released. Press the plunger in within 4 mm from the outer case edge surface and check the ohm meter. Depress the plunger and again check the ohm meter.
If you enter a curve too fast and start to lose control of your vehicle, you might not safely make it through the turn. Electronic Stability Control (ESC) is a feature that can help you avoid this kind of disaster. About half of all fatal passenger vehicle crashes on US roads involve a single vehicle. The crash studies indicate that ESC can reduce these crashes by more than half. ESC is an extension of anti-lock brake technology (ABS) with speed sensors and independent braking for each wheel. Additional ESC sensors continuously monitor the driver's steering input that can tell if the vehicle is pointed in the intended direction. On slippery roads, curves or in emergency maneuvers, the front end of a vehicle may start to plow ahead or the rear end may spin out. When this occurs, ESC brakes individual wheels to maintain control. They may also reduce engine speed to bring the car back into the intended line of travel. Modern cars and light commercials use tandem master cylinders to suit divided or dual line braking systems. A divided system is safer in the event of partial failure. Fluid loss in one half of the system still leaves the other half able to stop the vehicle, although with an increase in the stopping distance. A wheel's braking ability depends on the load that it's carrying during braking, so the type of vehicle is a major factor in how a brake system should be divided. A front-engine, rear-wheel drive car has around 40% of its load on its rear wheels, so its braking system can be divided in a vertical or front-rear dual split. This puts the front wheels in a different system from the rear wheels. If one half of the system fails, the front or the back, there is still enough braking capability left in the other half to stop the vehicle. But this doesn't work well for a front-wheel drive vehicle. A load around 20% on the rear wheels cannot provide enough braking force to stop the vehicle. front engine front-wheel drive vehicles use a diagonal split or X braking system. The left-hand front brake unit is connected to the right-hand rear brake unit, and the left-hand rear to the right-hand front. If one system fails, 50% braking ability is left in the other system. Dual proportioning valves maintain optimum braking in each system. Oversteering is when a car during a turn loses traction at the rear wheels and starts to spin. This is also called a drift because the car's rear end starts to slide out of the corner. It's more common in powerful rear-wheel drive cars when accelerating suddenly around a curve, or in cars with bad suspension. To correct this mid-corner, you can counter-steer turning the steering wheel in the opposite direction to the curve. If you want to prevent this from happening, you can use wider tires at the rear, or a thicker or stiffer sway bar at the front, or thinner or softer at back. Understeering is when the front loses grip and slides off the curve, which is more common in powerful front-wheel drive cars. To correct this on the road, release the throttle and lightly apply the brakes so the front can grip the road again. In order to prevent understeering, make the opposite adjustments, which are better tires up front and a more rigid sway bar at the rear, or more flexible at the front. So at the end of this lab activity, what we have done is, firstly, we have identified, explained and familiarized with brake components at the front and rear tire and in the engine compartment. Secondly, we have explained and demonstrated foot brake and parking brake operation. Thirdly, we have performed brake booster airtightness check. Fourthly, we have performed brake pedal height inspection and adjustment. Fifthly, we have identified electronic brake system applied in this car. Sixthly, we have presented the brake system diagram. And then seventh is we have explained the purpose of electronic stability control or ESC. 8. We have performed stop lamp switch check using an ohmmeter. 9. We have discussed the difference between a dual split brake system and a diagonal split brake system. And finally, we have differentiated between oversteer and understeer. Therefore, all the objectives and learning outcomes for this lab activity have been achieved successfully.